Hey everyone, today I'm going to walk you through how to give autonomous agents a real identity using Descope. By the end of this video, you will know how to register non-interactive agents as OAuth clients, store and broker downstream credentials inside Descope, enforce tool-level scopes on an MCP server, and wire the whole thing up to two n8n workflows that read from and write to BigQuery. Before we get into it, here are the prerequisites that you will need. One is a Google Cloud Console project where you can access a service account JSON file, an n8n account, and a Descope account, which is free to sign up for at descope.com. Now let's get into the architecture of what we're actually building. Here's a scenario. An organization runs one n8n workflow that reads from BigQuery and another that writes to it. The write workflow should only be triggered by specific users. Instead of giving each workflow its own copy of the BigQuery credentials and its own copy of the tool definitions, we route both of them through a single internal MCP server. That server authenticates its callers with Descope, enforces tool-level scopes, and fetches the BigQuery service account credential from Descope at call time. The agents themselves never hold that credential, and the tools are defined once. The key idea here is that the MCP access token only authorizes the call to the MCP tool. Downstream access to Google is obtained just in time, per request, using credentials stored in Descope. The token gets the agent through the front door, and the server fetches what it needs to do the actual work and discards it right after. Let me show you how this is set up, starting in Descope. So in the Descope console, let's go into the Agentic Identity Hub, and this is where everything related to the agent identity lives. If we go into MCP servers, this is the server that was created, and here are the two scopes that we defined, MCP BigQuery.read and MCP BigQuery.write. These line up exactly with the two tools that the server exposes, one for reading rows and one for writing them. Scopes are how we control what any given caller is actually allowed to do. Next, in connections, we store the BigQuery service account credentials. We created two of them, BigQuery read cert and BigQuery read write cert. This one is for read access, and this one is for read and write. This is the important part. The service account private keys live here inside Descope and nowhere else. They're never copied into a workflow or checked into source code. Now we can go into clients, and you can see that we create one agentic client per workflow, and both of them use the client credentials grant type. If I click into the read one, you can see it has the client ID client secret, and this is the non-interactive OAuth flow. There is no human at the keyboard clicking approve on a consent screen. The agent authenticates entirely on its own using its client ID and secret. So we end up with two clients, one for read and one for write, each with its own dedicated identity. And now if we go into the n8n workflow, each workflow is scoped to exactly what it needs. I'm currently in the write workflow, and here you'll see that the scope only asks for MCP BigQuery.write. The MCP server checks the scope on every single call before it runs a tool, so workflow can never call something it wasn't granted access to. Same with the read workflow. If you notice here, the scope is MCP BigQuery.read. The boundary is enforced at the token and the server, which means that editing the workflow can't quietly escalate what it's allowed to do. Now let's look at the workflow as a whole. Each workflow follows the same simple shape. There is a trigger, a step that fetches a Descope access token, and then the MCP client node that calls our server. In the fetch Descope OAuth token, the first real step authenticates to Descope. We make a request to the Descope token endpoint using the client credentials grant type, passing in the workflow's client ID and client secret, and the scope that it needs. Descope checks the policy and hands back a scoped access token, which you can see over here. That token then flows into the MCP client node. We point it at our MCP server endpoint, set the authentication so the token is passed along, and select the tool that we want to call. For this workflow, we pick BigQuery read and fill in the project, the dataset, and the table that we're reading from. Now if I were to execute the workflow authenticates, calls the tool, and the rows come back straight from BigQuery, as you can see here. The agent never touched the Google credentials, it just presented a valid scope token, and the server did the rest behind the scenes. The write workflow is structured similarly. The only difference is that this is pointed at the BigQuery write tool, with the write client and the MCP BigQuery write scope. The one extra thing we do here is gate the write workflow in n8n so that only the users who should be allowed to run it can trigger it. This gives us a clean separation of responsibilities. The n8n control decides who can start the workflow, and the Descope policy decides what the workflow's agent is actually allowed to do once it runs. So now, here's the values that I'm sending to write in the write workflow, and if I click execute step, It should successfully do that for me. It is worth walking through what actually happens inside the server on every single tool call. First, the MCP client calls a tool with its access token. The access token I added over here, which can be edited once it expires. The server validates that token and checks that it carries the scope the tool requires. It then reads the caller's identity from the token subject claim. Next, it calls the Descope Management API to fetch the right credential, choosing the connection based on the tool. The read tool uses the BigQuery read cert, which we saw over here in the connections, and the write tool uses BigQuery read write cert. It pulls the service account JSON out of that response, signs a short-lived JOT assertion with the service account private key, and exchanges that assertion at Google's OAuth endpoint for an access token. Finally, it uses that token to call the BigQuery REST API. The beauty of this is that the BigQuery tools are defined once and can be exposed to as many workflows as you need. The credentials are stored once in Descope instead of being copied into every workflow. And the permissions for each workflow also live in Descope rather than something you have to maintain by hand in n8n or the server code. So that is identity for autonomous agents with Descope. What we ended up with is a holistic identity layer for our agents. They authenticate through a non-interactive OAuth flow, they request delegated and policy-backed access to resources, every credential stays locked inside Descope, and every action is scoped and auditable. If you want to try this yourself, you can sign up for Descope and start building identity journeys for autonomous agents today. The link to sign up will be in the description, as well as the blog that goes through what we did in this video in a little bit more detail. Thank you for watching, and I will see you in the next one.